So this is a movement tutorial for GoDot 4.3 or GoDot 4.3. So first things first, you need GoDot 4.3. You need the C# version installed. As you can see, I've got some other projects here. We're going to go ahead and do this. So you're going to go to create new project. I'm putting mine in compatibility mode just because this is a tutorial for a lot of different things. If you're using version control, you can use Git. I think that just generates a Git ignore. You don't need to worry about it, but we'll name it movement practice. Make sure you have it somewhere where you'll not forget it. So I'm going to go ahead and put it in my tutorial test here folder, since I've already set that up. And then you're just going to go create and edit. Now, GoDot's going to open, and this is the first screen you're going to see. It's going to be in 3D mode, but we're making a 2D game, so we're going to swap it over to 2D. This is a scene. GoDot, everything's either a scene or a node, and actually I think scenes still technically count as nodes. So the first thing you're going to do is create a new 2D scene. This will be the root of our game, so I'm just going to call it game. Hit save. Now this, you'll get a little save as screen. Res is the root path for the game directory, and because I decided to be smart with how we're naming this, we're just going to name this scenes, and then all of our scenes will go in here. So we'll save game.tsn, and now as you see down here, you've got a scenes folder, game.tsn. You can also make stuff in here. This is just a file system editor. It's not 100% necessary. I just find it helpful. Some things I should mention: positive on the x-axis in Godot is this purple line, and positive y is actually down. So if you want a positive x and y, it'll be in this quadrant right here, which is why I kind of put that thing up to the left. Now, like I said, in Godot, everything is a node or a scene. So first things first, we're going to need, something for our character to jump on, some sort of platform. So what we're going to do is click this plus button up here that says add a new scene. That'll create a new empty scene. Now before, when we did that for this thing, we clicked on this 2D scene node because this is the full game node. So this is where the root node, we don't really care what's at the top. We don't need anything special. But this node we're making right here is going to be a platform. So we need it to have some sort of collision and some other properties. GoDot has a node for that. So what you're going to do is you're going to come down here and click other node. You're going to open up and expand the node 2D and then the collision object 2D right underneath that. Then you're going to go over here and click physics body 2D, and you're going to create it as a static body 2D. You notice down here it says it's a physics body 2D that can't be moved by external forces. This is what we want. We don't want something to be pushed to push our static platform that's floating in air. So we come up here, create a new static body 2D. And as you can see, it has this little warning. This warning says this node has no shape. It can't collide or interact with any other object. In order for any body in Godot to collide, it needs to have a collision shape. So first things first, we're going to actually come up over here and name this platform. So just remember what we're working on. And then we're going to need a shape for it to collide with. So there's a couple different ways to do this. The way I'm going to show you now is one way. There's another way to do this as well, but this is the way I always do it. So I'm going to come over here and click this icon.svg. By default, every Godot instance starts with this icon.svg. It's just kind of a placeholder, but it's perfect for what we need. So if you come over here, you notice it's created something called an icon or a sprite 2D. This sprite 2D has a bunch of properties we don't need to worry about right now, but for this tutorial, we'll come down here to the position and we'll just reset it so it's centered at 0, 0. Then, because this is a platform, we want it to be wide and not tall. We're going to, first things first, come over to scale and click this unlink button. That way we can edit one of these numbers without changing the other ones. Then we're going to change this y to 0.2. Hit enter, and as you see, we have a very wide and very flat image now. This will be our platform. We'll go ahead and click save for now. Put it in scene since it's a scene and save it. But as you'll notice, we still have this warning here because sprite 2D does not automatically count as a collision object. So what we're going to do over here is we're going to come up here to sprite 2D. While it's selected, click on this and you'll see create collision polygon 2D sibling. This will automatically create an outline of this platform as a 2D sibling of it, meaning it'll just create it in the same shape, or its best approximation of the same shape. You've got some settings down here, simplification. This is going to change how closely or how far apart the line is to the thing. So as you can see, we've got some curves here. Obviously they're pixelated and pixels aren't really curved. So if we set it to 0, or I guess 0.01, and then we shrink it, or we set this grow to 0, and we update the preview, as you can see, it's now going to do its best to perfectly match this image, this shape of this object. But this is a platform. We don't really want that. So if we set simplification to 1 and update preview, now you can see there are still some points, some like edges, some ledges of no return, but it's a lot smoother. And then if we set it back to 2, which is what it started at, now you can see it's even smoother. You've still got some rigidness, you still got some bumps, but it's close enough and it's not an exact match. This is what we're going to do. This is how we're going to create it. So simplification set to 2, grow pixels set to 0, and we're going to create collision polygon 2D. Now, as you can see, this icon is overlaid by this red. This red is the collision object. This is the actual collision thing that's going to have physics rendered against it. So there's a couple more things we're going to do. Now that we have this collision polygon 2D, we're going to go ahead and select it. Then we're going to go down over here to build mode solids. Okay, that's already set up. Nice. So then what I'm going to do is, just because I don't like staring at this red thing unless I absolutely have to, I'm going to set the icon as a child of the collision polygon. So now, as you can see, they're both set up like this. But right now, as we have it, if let's say I want to move the shape, let's say I actually wanted to set over here, oh, they're not linked. This icon, this sprite 2D is not inherently linked to this collision polygon 2D despite being its child. And if I move this, they move together. The icon is set to the bottom, so I select it first, since inputs are registered in reverse order of the scene of the node tree in Godot. So what I'm going to do is I'm going to come over here to this, click on the collision polygon 2D, and click on this button right here that says group selected nodes. Click on that, and then you click on this and group them again. And now these two nodes should be grouped together. So when I move this, the entire shape moves. The collision polygon 2D and the icon move at the same time. That's just a kind of convenience thing for moving it around. So I'm going to reset that, save it, and now we've got our platform. Now platforms and now scenes in Godot kind of act like prefabs in Unity, and that you can just drag them into one another. So as you can see, platform is a separate scene, game is a separate scene, but I'm going to drag this platform into game. I'm going to set it just here. As you can see, this platform has been added to the scene tree as a child of the game node, and it is self-contained. Although it's, as you can see, a separate scene. If you click this, it'll just take you back to this editor. But so now we're going to have a second platform over here and just leave it here. So now they've got two platforms to jump between. Save the game scene so you don't lose it. And actually, one thing I did forget to do. So just like in Unity, Godot has collision maps and collision masks. Right now, I'm going to pretend that the player will be on layer 1 and the ground will be on layer 2. So I'm going to deselect layer 1 for collision and select layer 2 here. I'm also going to leave the mask at layer 1 because this will tell us what it can and can't collide with. And since the player will be on layer 1, we want it to collide with the player. Now saving this here, since this is a scene, should update it in these other two platforms over here. So if we come over here, yes, as you can see, it's been updated here. So if creating a separate scene for something is a great way to kind of isolate different parts of your game. But as you can see, this doesn't have a physics material. So you just come over here, new physics material, and that's all you really need to do. So now they all have physics materials. They're all set up to collide properly, and they don't have any inputs. Now we need a player for our little game. So what we're going to do is here, once again, come over here, create a new scene 2D. Click on other node, go to node 2D, go to collision object 2D and physics body 2D, and we're going to have character body 2D. Character body 2D is specifically created for players. Specials and characters moved by a script. Now, because we're doing this in C#, I'm actually going to rename this to player. Because we have the .NET version of Godot installed, there's no script that's automatically generated with the player. So if we do the same thing I did last time, come over here, drag this in, reset the transform. We're actually going to link this back and scale these to 0.1. It's pretty small for a character, but for now it'll do. Save it, player as a new scene. Once again, it's a player right now, it still needs a collision shape, so I'm gonna do this. I always set my player to have be exact just because I'm weird like that. Create collision polygon 2D. Once again, drag this here. You can control click as well to select multiple if you don't want to click twice to link them. But I always just click twice. So now they're linked. So we've got a player body 2D. We've got a game. We've got platform. So if I drag player into the scene, you'll see, and we hit play up here. Save play. Select the current scene. So when you hit, I should explain the difference. So I hit this play button that was over here. Let me close this. I hit this play button that was over here. This is the run entire project. This will run your game from the beginning. If you want to run any specific scene for whatever reason, let's say you have a platform scene and you've got it set up to move back and forth and you know to test it, you're going to click this run current scene button over here, the one that has a play button on this. This button runs a specific scene. So if you want to run the player scene, let's say you've got several levels in your game and you want to run a specific level after making changes to the player, you can click this button and then select the level scene that you want to run. So I'm going to run the whole scene. And as you can see, there's several things wrong with this. First of all, the camera is way too far away. I can barely see that guy up there. He's so tiny. And on top of that, our player isn't moving. Doesn't matter what buttons I click. It doesn't matter if I use WASD or arrow keys. Nothing's working. And he's just staying there. He's got no gravity. He's got no nothing. So those two things are the first things we're going to address. The very first thing we're going to address is the fact that the camera's too far away, because I like to be able to see the player when I'm playing a game. So we're going to come over here. We're going to select this player node as the root again. Come up here to child node, and then we're just going to search camera. As you can see underneath node 2D, there is such thing as a camera 2D. There's also an XR camera 3D and a camera 3D, but that's for, I believe, AR and VR, and this is for just 3D games. But we're in a 2D game, so we're going to play with the camera 2D. Now, since the camera 2D is a child of the player 2D, every time we move the player, the camera should move. And now, instead of being centered on, well, the center of the scene, it's centered on the player. As you can see, this entire box is what the scene is going to show. So if we go back to the game, you can see this is the camera. This is how big it's going to be. Let's hit play to test it. Beautiful. Now my character's in the center of the screen, although I don't necessarily like how far away it is. So we can fix that. Go back to camera, go back to player, click on camera 2D, and you'll see this zoom feature. Now this is not, this is zoom. I don't remember what the inverse of zoom is, but when you increase the zoom, it's going to get smaller, and when you decrease, it's going to get bigger. So if we set the zoom to 5 and hit play, now I can see my character. He's in the middle of the screen, and I can see this first platform. I'm going to set the zoom to 4. That's just what I found works best for a player, just so I can see more around. It's a pretty good average thing. The next thing we're going to do is the player can't move. He can't jump. He doesn't even fall down due to gravity. So what we're going to do is we're going to add a script to him, because the player movement script, thankfully in GoDot, is automatically generated. So we're going to select the player and then click this button up here that says attach a new or existing script to the selected node. We're going to click it. And if you notice here, it has a new path, scenes.gd. We're not in GD script. We're doing this in C#. So we're moving it. So change this language to C#. It inherits character body 2D. The template is the character with basic movement. We're going to use this for now because this is basically everything we need already. This is the path. I'm actually going to change the path. I'm going to create a new folder called scripts. Now this isn't the only way to set up your paths. It's also possible to have group by things. So let's say you have your player, and then you have a group of players, or you have teams or something, and those require separate scripts. You can just have like a interactables folder with all your player scenes and scripts in it. I'm just doing it like this because this is how you do it in Unity. So we're going to click create, and it's going to open up. For me, I have it set to open up in VS Code. For you, it'll probably open up in a script editor over here. If you want it to open up in VS Code or whatever other thing, you're going to have to go to editor settings, and then I believe you search editor. Let's see, text editor, external. You go down to text editor, select this external path, and you have to set up the executable path. So I have it set to go to my programs my VS Code and open that automatically with the flags go to file line column, project dash dash go to file line column. This will make sure that it opens in your proper. So this is how it works for VS Code. This will make sure it opens the correct script at the correct line and column that your cursor was already at before. If you want to use a different program other than VS Code, you'll have to go out and find out what the command line arguments, because these are just command line arguments for that thing. After that, you'll save and close. I don't know if you'll have to close and reopen the editor or not. I already set that up a while ago. But yeah, if you're in this and you ever want to get back to the script, you can click on this script here and it'll automatically bump you back. So this is the script that's automatically generated for the player. It's basically got everything you need: speed, a jump velocity. And if you'll notice, the jump velocity is negative because the Y positive is down, so you want to go up. There are a couple things that I want to explain here. We have the physics process, velocity. So in Godot, you can't actually, velocity as it is not something you can override parts of. You have to just set it. It can only be set or read. It can't be updated. So you'll have to get the velocity into a local variable, and then you can do whatever you want with that variable. So you see here, if it's not on the floor, then you want to add gravity to it times however much time has passed. Then there's a jump action, which is UI accept. We'll worry about this later. These UI accept, UI left, right, etc. We'll change those later. But for now, just know those are the arrow keys, and this is the space bar and the enter key. And then here's the rest of the movement logic. It's all auto-generated. You really don't need to update this. And then there's a function down here, move and slide. So move and slide means that when it hits, when a character hits a surface that doesn't move, it's going to slide off of it, in a sense. That can be changed to move and collide, and there's a bunch of other variations on that, but we won't get into that here. All we need to do now is, since this player script has been generated, we go back to the game and we hit play. Voila, we're in the game, and as you can see, gravity just sent us through the floor. We can fix that by going over to this collision and selecting 2 as the mask, because remember, the layer that it's on is where it exists, and the mask is what it's looking at. So if we had multiple players and we wanted them to be able to collide, we would mask 1 and 2, because layer 2 is the ground. Go ahead and save that, hit play again. Boom, now we're on the thing. Right now, left and right arrow keys move us, and space, well, makes us jump if we don't fall off the edge first. Let's double check that. Boom, now we can move and jump, we can collide, and we can fall in the gap because I'm bad at gaming. There's a reason I never made it far in Mario. Now, moving forward, what we're going to do is change those inputs. So if you notice here, if we go back to player and click the script, these inputs are UI left, UI right, UI up, UI down, and UI accept. I don't want those to be the same thing. I want to be able to use WASD because that's the standard thing. So what you're going to go to do that is go up to project up here in this top corner next to scene, go to project settings, and then you'll see general is the currently selected tab, and you're going to go over to and select input map. Now input map, as you can see, it looks like it has nothing, but if you show these built-in actions over here, now you can see everything. So as you can see, UI accept is currently set to enter, KP enter, which I think is just the opposite side of the keyboard, enter, and then space. And then the other things we had were left. So that's the arrow key left, and then you've got the joypad access, etc. These are all pre-built in that you can just use as they are. You don't need to change anything, but I am different. I want to be different. I want to be quirky. I want to make my own action. So we're going to come over here and click on this space that says add new action. We're going to name it game underscore left. And then if you hit enter or click the add button, you'll see a new category comes up. Then you'll come over here, hit this plus button, and there are 2 ways to do this. You can either come down here and search for the input using filter inputs, or scroll down in all these things, or you can simply enter the input, and that's called filter by event. So game left, we want to move left, that's A. A, physical A, or Unicode A, that's already set up. We don't want it to be Control, Shift, Alt, Shift, Control, Windows, any of those. So we set that in, and boom, now game left is A. We're going to come over here and add it because I want to be accepting. I'll also do the left the filter inputs. We'll actually do that. Hold on. I'm going to do that with the filter inputs so you see how that works. You filter inputs, you look up left. Now we've got several things. We've got the mouse inputs for left, mouse wheel left, left mouse button. We've got the joypad left, which is the touchpad. We've got the joypad axis if you want a left stick. And actually that's what we'll do, but I'll come back to this later. We're going to click left here, click OK, and now physical left has been added as an input. So now you can use the arrow keys or A. But what about people on controller? Let's say they want to use joysticks. Well, we come up here, we can get rid of this filter, and then we come down to joypad axes. And now you can see axis 0 is the left stick, joystick left 0. We'll click that, and boom, now we have game left. We're just going to do the same things, game right and jump as well, or for game right as well. So game underscore right, enter. I'm just going to do this all listening for input because that's the fastest way to do it. It's this, and then joystick. It's not that hard. You come down here and you click the opposite of what you clicked before. Boom. Now we have new actions, game left and game right. So we're going to close this. I'm going to come over here and we're going to replace these. So now instead of UI left, UI right, UI up, and UI down, we're going to go with game underscore left, game underscore right. Click save to make sure it saves. Open up the Godot editor again. You'll see this inspector might be out of date. Please build the C# project. Now, if you want to see everything that it was in the script reflected and updated in this inspector, then you're going to come up here and click build. And this is just build. This will just build the .NET project. It's building the C# project. If we hit play again, you'll notice that now I can use A and D to move left and right and space to jump, and that still affects. It still runs properly. So that's great, but if you'll notice in the game, I'm actually going to start it over again. You'll notice in the game, when you jump and fall through, oh no, I've fallen, but you don't die, you don't respawn, you just fall infinitely, basically. To fix that, we're going to add a death plane. So go back to the game node, click on this, and what you're going to do is click new node, get rid of the filter, and then we're going to start here. So you go to node 2D, collision object, but instead of going to physics body, we don't care about physics, we just want the area 2D. And if you notice, it's a region of 2D space that detects other collision objects entering or exiting it. This is what we want. As you can see here, it has no shape. Now, if we wanted to do multiple death planes, or let's say you wanted to make this a kind of prefab, you can do what we did before. So we'll delete this area 2D, we'll come over here, create a new scene again, node object, and then you'll go to the same thing as select area 2D. We'll call it death plane. And then, actually, you know what? No. We'll do it all in this editor so you can see that it works in both ways. So you don't have to make everything a new scene. Come over here to the collision object, go to the area 2D, create area 2D, rename it to death plane, and as you can see, it's an area 2D, but it's also a collision object, so it needs a shape. So in order to give it shape, we'll right click, add child node, node 2D, and instead of going into collision object 2D, for some reason they decided to put collision shape and collision polygon should be outside of the collision object 2D. Stupid choice if you ask me, but they didn't. So we're going to go create new, you're going to create a new shape, collision shape 2D. And then we're going to come over here. As you can see, there's no shape that's been generated. It's just an empty thing. And so you've got the same problem. A shape must be provided. We're going to go over here and we're going to create a new rectangle shape 2D. And voila, we've got this plane, this area of existence that'll tell us when something collides with it. In order to do that, we're going to drag it down here. And we're just going to expand it like this because I'm lazy. We're not going to do any like crazy things. We're just going to expand it like this. Now, this is a collision area 2D, but it's also, but remember, this is still a collision object, so we need to set the mask. The player is on layer 1. We'll set this to be layer 3 because just to keep things cohesive. This will only really matter if you're doing like large projects with multiple levels and scenes and all kinds of crazy interactions. But it's good practice to kind of get used to working with it as it is. So the death plane, we'll put it on layer 3, but we'll mask it to layer 1 because we want it to collide with the player, or we want to know when the player enters and exits it. Because it's not a physics body, there will be no actual change to the player. We'll just know when the player enters and exits it. Now I'm going to teach you about a thing called signals. So we want something to happen to the player when it enters this death plane. Preferably it dies or they respawn or whatever. But in order to do that in Godot, we're going to go over here to node, and we're going to work with something called signals. Now, as you can see, when I click collision shape 2D, there's a different set of signals. These are the kind of base signals that are sent out, that are emitted every time these things happen. So every time it's drawn, you can get the draw signal hidden. If for some reason it becomes hidden, anything like that. But you'll notice the signals for collision shape 2D are different from the signals for player, which have a collision object. This has its own set of things, but it also has the same things as the root node. Same thing if we click on platform 2, they have collision objects 2D, and so they have those same signals. But when you'll notice, if you click on the signals for area 2D, you get this whole extra set of collision of signals, and that's what we're going to work with today. You have area entered, which when another area 2D enters this area 2D. So if you want to have special collisions with areas, you'll use that. There's area shape entered, which is different. And this is basically if there's a shape 2D, so like collision shape 2D that enters it and not just another area, you can get the shape and you can get the area that entered it. The one we're interested, however, is the body entered. Body entered is a MISIC when a received body enters this area. It can be a physics body 2D or a tile map. So the player, if we go up and click on it again, remember, is a collision objects 2D. That counts as a physics object. That counts as a physics object 2D. So that's what we want to know. What we're going to do is we're going to go ahead and double click on body entered, and we're going to link it to the player. Now there's a couple different ways to do this. You can pick it in here. If you have any predefined methods that'll show up in here, you can click and it'll show. But we just want to select it to the node, so we'll do that. And remember, since we're working in C#, we're going to have to rename this. So we want to go on death plane body entered, capitals. Okay, so now we have the name on death plane body entered. We're going to hit connect. Now remember, in Godot, since we're using the C# version of Godot, there is no automatically generated method. So when I come over here, that method doesn't exist. If we were using the GD script version, that method would automatically be generated and we wouldn't have to do anything about it. But it's not. So what we're going to do instead is we're going to come over to the player script again. I'm actually just going to put it above it because I don't know, I feel like it. I'm going to go public void and then paste the same name. I copy pasted it. Enter 2D. This is a C# script, so make sure you follow C# naming conventions. And for now, we're just going to print that it's been entered. So gd.print is the print function, quote, and I'm just going to say dead. When it enters the plane, set dead. Save it. Come back and run the project. Let's see. All right, now let's see what happens. Oh, we've got an error in the debugger, and as you can see here, nothing printed. Go over to the debugger error calling from signal body entered to callable, the function we created, method not found. And despite us, but you say the method's right here. This is the name of a method, but it's not set up properly. If you notice, when you link the signal, it comes with something called a node 2D. In order for signals to link properly, they have to have the same variable layout up top as they do with the name. So they have to match perfectly. So we're going to go back into here and we're going to make it take a node n. Now node is the root class for everything in Godot. So node 2D does inherit from node. So having a node there will be good enough. So now if we hit play, we go over here, we fall through, dead. Beautiful, that's what we wanted to see. So after that, we've got it to print dead, but we want it to do something to the node, to the player that entered it, right? So because this is the player, we just have to do this dot, what is it, free q free, there we go. Q free, this will destroy the player, this will destroy this node if we hover over it. Cues this node to be deleted at the end of the current frame. When deleted, all of its children are deleted, as well as all references to the node and its children become invalid. That's what we want. So we want the player to disappear, basically, after the game stops. We also probably want to quit the game. Well, for now, we'll leave it at this. Let's run it and see what happens. Boom, player disappeared, and because the player disappeared and all references to it disappeared, so did the camera, so now we're back zoomed out. That's just a basic movement tutorial and collisions tutorial in GoDot 4.3. Thanks for watching.